Hello guys, Matt is back with another video, and today we'll be looking at the second problem on the Project Euler website, on the Project Euler archive, which is the even Fibonacci numbers. So we'll be finding the sum of the even Fibonacci numbers. So we're here to learn about Fibonacci numbers, what they are, and then we'll learn. Then we'll solve the problem. So for the new people, if you haven't already subscribed, please click on the subscription button below so you get notified whenever I release a new video, because I'll be releasing a video every day for the next 48 days. So yeah, let's go. So I've already copied the question from the Project Euler website, which is down here. If you're new and you're studying with us, you can look at the first problem if you're interested. It'll be in the upper right of this video. Should be popping up right about now, so you can get an introduction into the series. So this is our problem here. Let me just show you where I found it. So if you go onto your browser, and then if you go to projecteuler.net/problem equals to 2. So this is the problem definition over here. So this is where you will see it. So we'll only come back to this side when we want to actually test if our solution is correct. So let's go back to the problem. So the problem says each new term in a Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So before we can go ahead and start answering our question, so actually I'm just gonna close this section on the left just to give us more space in the code. So I'm just gonna click on there so we can close that. So yeah, this is the file that I'm looking at. So yeah, before we can start solving our problems, let's pick the problem apart. So first of all, we need to understand what a Fibonacci sequence is. So they've defined it for us here. A Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, so these would be your starting point of your sequence, and then you will continue. So assuming that we have been given these two starting points, that means to start off with we have 1 and 2 over here. And to get the next term in our sequence, they say you add the previous two terms. So the previous two terms in this case is what? 2 and 1. 2 and 1, if you add them together, you get 3. And then now to get the next one after 3, you look at the previous two. The previous two would be what? 3 and 2. If you add them together, you get what? You get a 5. And then if you have your 5. So if you want to get the next term in your sequence, what do? You look at the previous two, which is what? 3 and 5. So, and then you get 8, so on and so forth. So that's what our Fibonacci sequence is. So, and a Fibonacci number is any number that's in the Fibonacci sequence. So 1 is a Fibonacci number, 2 is a Fibonacci number, 13 is a Fibonacci number. So now the second part of the question says we should calculate the sum of the even value terms. If we're just looking at the first 10 over here, that means in this group over here that we're looking at, we'll add 2, 8, 34. Yeah, those are the numbers that we'll add. So now we just need to solve the problem. So yeah, so let's just call it, I'm going to create a function calling it the even Fibonacci think that's how you spell it. Yeah, even Fibonacci sum. We have a limit of 4 million, right? So that's our upper bound of the numbers that we're trying to get the sum of. So we can define the limit. Sorry, we're going to define the limit over here. The limit, which is going to be 4 million. 1, 2, 3, 1, 2, 3. So how are we going to find our Fibonacci numbers below 4 million? So we have 4 million as our upper bound. So once our Fibonacci number is 4 million, that's when we stop. So in the Typescript Essentials course, we learned about the while loop. So that's what I'll choose to use over here. So while the Fibonacci number we have at the current moment is not greater than 4 million, then we continue finding our Fibonacci numbers. That's what we're going to do. So yeah, so we can say, well, while some number over here, I'll just underscore over there, we'll define it after this, while our undefined number over there is less than 4 million. Actually, less than or equals to 4 million, right? So actually, I don't need to do that. I can just, because we already stored our limit over there. So we need to store our Fibonacci number over here. We can do it in two ways. We can choose to add our numbers into an array, or we can actually store the numbers into variables. So, but I think the best way is to actually store them in an array with our starting point. So if you look at the problem up here, you have our starting point, which is 1 and 2. So you can actually go sequence. I'll just call it our sequence. Sequence equals to 1, 2, which is our starting point, right? Number. So it's our array of numbers, right? That is our sequence. Now that we have our sequence over here, right? What is our current Fibonacci number? Our current Fibonacci number will be 2 in the array, right? And 2 is actually at what? At position 1 in this case. So we want to check if our current Fibonacci number is less than the limit that we have, right? So if I create an iterator, which is what we're going to use to loop to to add values in our array, and to keep track of the current Fibonacci number. So to start off with, since our current Fibonacci number is 2, that means our iterator should be what? Our iterator should be 1. And then now while, so we can actually now that we have our Fibonacci number there, we can say while the sequence at, this would be our current Fibonacci number. So while that condition is true, then what do we want to do? We want to check if that Fibonacci number is actually what? So what I'll do here is I'll actually do this. I'll just create I'll call it a Fibonacci number. So current Fibonacci. Yeah, I'll call it current Fibonacci, and I will actually do this to it. So that is our current Fibonacci. Our current Fibonacci number. I'm just giving it that variable there, so we can actually use that guy over there. So yeah, while our current Fibonacci is less than the limit, then we will execute the code in this block. So yeah, now if our current Fibonacci number is divisible by 2, because that's what the question is saying here, find the even value terms, right? So if this guy is divisible by 2, that means if this condition is true, then we want to sum the numbers, right? So that means we need to keep track of our sum outside of our loop to start off with, right? So I'll go let sum equals to 0, and then that means in here, well, actually it's actually this this the syntax that we can use, which is the plus equals. So we've learned a lot about the plus plus and the minus minus. So we can actually use this. So what this statement over here is saying okay, take the current value of sum. So this is actually equivalent to saying sum equals to sum plus the Fibonacci number. These two things are the same over here. So this is the shorthand of this guy. So you can actually use this instead of that. So I'm going to do that there. So now that we've calculated the sum, we've updated our sum over here. We also need to update our Fibonacci number. Update our Fibonacci number by what? By calculating the new one. So the new one would be the previous two added together. So now we're going to say our current Fibonacci number now should be what? Current Fibonacci number should be the, so now in our sequence we have that guy. So we add the previous two. That means we have I, right? So we add the value at I plus the value at I minus 1. So we add them together. So that's what we're going to do there, minus 1. That's then now we have our new Fibonacci number. And also after doing that, we also need to add 1 to our I. So now, yeah, because if we don't update there, I won't change. And if I doesn't change, this guy will stay in an infinite loop, because this guy will keep on calculating the same thing forever and ever. This Fibonacci number, because if we don't update I will be the same here, and I minus 1 will be the same. So we need to update our I so that we continue, right? So yeah, this should actually bring us closer to our solution. But what we need to do now is we need to add our new Fibonacci number to our array. So what we're going to do is go sequence dot push, not splice, sorry, push the Fibonacci number. So yeah, so now we can actually look at the sum, log the sum after we are done. So I'm just gonna do it like that, and then there, and then that's our code. So we're gonna use TOS node to run it. So if you look at my folder structure, I've created a folder here called source src, which is for source, and then my even Fibonacci number is in there. So to run it, I'll go source even Fibonacci, and then I'll run that over there. Oh, nothing will happen because we actually did not run the function. So you can just run the function there. So yeah, so that is our sum. So let's just go and test if this is actually the right the correct answer. So I'll go this side. So I've already logged in. If you haven't logged in, log in so you can test your answer. So I'll paste that over there, confirmation code there, and then no 34 yeah 04234, and then we got the answer. So yeah, so now let's go back to our code and see if there are things that we can improve on, right? So I saw one thing we could be doing is actually this guy over here, the value of I. So we actually the value of I can just be sequence.length minus 1 at any point in time. Because if I'm just gonna, let me comment this code out, do this, we had the value as 1, right? And then here, when you update, every time you update, the value of I, you actually add something to your array. So this guy can always give us the value of I. So we can leave it as 1 here, but we can copy this guy out, and here we can just do that. After we add something to our array, we can just go I equals to that, and then I believe this should give us the same answer, right? So let's just try run it again. So look at that, same answer. Yeah, and one other thing, we can make our function limit dependent, so that we can have this guy here as an input. Remove that guy, and then we can feed our formula in here, so that we can reuse our code for different values we don't need to change the body of the code. We just actually give it a different parameter. So you can actually here run it for 3 million, right? And then you can here run it for 1 million and see the differences. So if we didn't do it this way, that means we would have to run it once, change the value of the limit in the code, run it again, change the limit of the thing in the code. So if I run this now, we'll get the result of all of them. Yeah. So these two are actually the same, funny enough. So, and instead of logging the sum inside, we can actually just return the sum to us. And then I'll just go console.log and log these guys over here. I'll do that. So this will be for 1. This will be for 4, sorry. This will be for 4, this will be for 3, and this will be for 1. So here, instead of that, we can have commas instead of that. Yeah. So now, running it again. So now we get those things over there. So which is, this is for 4 million, this is for 3 million, and this is for 1 million. So yeah. So we'll look at the third problem in the next video. Is there?